Welcome back, students. So in this lesson, we want to talk about work and how you calculate it. And so let's begin by talking about energy. In the last one of the previous videos, we had talked about this concept of energy being equal to the ability to do work. And I had mentioned that we were going to eventually talk about this idea of what work was and how we calculate it. And so, if you read in the book, in the text, you would have read that work can be defined as this concept of force that is going to be applied to some object and it's going to cause some displacement. So, the idea here is if I have, for example, a box here, I'll do my best here, and if I apply a force, and let's say that the force is being applied here by this green arrow, if I apply the force, and let's say here that the box is going to be here at this particular point here at point 0, and let's say here 0 feet. If I go through then and provide this box, and let's say that the box moves from this particular position here, and it moves over here, say 10 feet. Well, the displacement between these two boxes here will essentially allow me then to say that this is some distance that was traveled. And for us then, we can say that for this example here, that work would be equal to the force that was applied times that distance that the box was displaced. And we can calculate this, we can measure it, and it's fairly straightforward, and we can definitely do that. Now, the idea here, though, and just to clarify here, the force is going to be in this unit of newtons, and the distance here is going to be in the unit of meters, just so that you know that. And then the final units for work, one of them is Newton meters, just FYI. But the idea here is, well, we're not talking necessarily about moving boxes or moving objects from one location to the next in the world of chemistry. Typically in chemistry, what we're talking about is we're talking about molecules or particles in a solution, and we're really talking about whether it's going to increase its kinetic energy in the system, and maybe perhaps a liquid or maybe perhaps a gas. Or maybe when you go from a solid moving it into a liquid, or from a solid into a gas. We can talk about that, but we're not going to be using forces and displacement. What we're going to be talking about here is we're going to be dealing with the concept here. If I kind of put this at the top, we're going to be dealing with this concept of volume and pressure. And so for us in chemistry, we tend to use a different equation. And for us, the equation of work is going to be slightly different. We're going to talk about work here for us, W, as equal to the product of pressure times some change in volume. Now, before you go any further, keep in mind that when we're talking about this change in volume, if the volume is going to decrease, or if there's a certain amount of force being applied that reduces the volume because of some external pressure, then the pressure here is going to be a positive value. But if we see that the expansion of volume is going to go from some small volume to a bigger volume, then obviously the amount of pressure that's being exerted inside that particular system is going to be less. And so the pressure here is going to wind up being a negative pressure. And so it's important that we understand this, because how we define work is going to be important for how we proceed moving forward. Okay? And so this is an important concept. And so along with this, though, as we can also see here as a way of looking at this, is if you have an increase in volume, so let's say that you have volume increasing, what this is going to happen, or what's going to happen here, is that this is going to lead to a reduction in the potential of this system to do work. Okay? And so very, very important concept. Now, the other item that we want to talk about is, how do we define work in terms of our ability to call it is this going to be a positive value for work, or is this going to be a negative value for work? And whether it's positive or negative is going to have some serious implications for us. If the work is going to be positive, and so let me see if I can move some of this stuff around here. And so let me see if I can move some of this stuff down. Let's move this over here to this side, and then we'll move this part here. See if I can move them over just a little bit more. And then we can move this over to the side. Okay, so what we need to consider now then is what happens when work, whether it's positive or whether it's negative. Okay, and so we'll just say here this is going to be work W positive and W negative. And so the idea here is if work is done because what you're having here is an expansion of volume, then the work value here is going to be a negative value. Okay, and essentially this means that you are going to engage in losing energy. Okay, and essentially this is going to be work that will be done by the system. Okay. On the other hand, though, if work is positive, and what's happening here, think about it kind of like it's like a checking account. If you have positive work in this particular case, is because you are absorbing some additional energy. Someone's kind of placing that upon you, and so here for work, what's happening here is that energy is being absorbed. So we'll just say you're absorbing energy. And what this is going to do is that this is going to be work done onto the system. And typically that's going to be as a result of the surroundings acting upon the system, as opposed to the other way around. And so these are very important concepts to know when we're dealing with work. And so in the next couple of videos, we're going to kind of bring these items here with work. We're going to put them all together as we start to look at how work and energy, or this heat concepts, are tied together. Okay. And so if you haven't already subscribed, please make sure you subscribe. Keep watching, keep learning, and we'll see you in the next video.